Alright, so in this video I'm just going to demonstrate the way to find out how the magnetic field is moving and how to determine the magnetic force um, using uh, two right-hand rules. Um, Magnetic fields are it's just like um, if you were to have a magnet, the magnetic field would be um, that surrounding area that uh, the magnet affects. Um, Whereas the magnetic field is going to be used with the right hand rule number one, and then the magnetic force, which is going to be uh, discussed with the right hand rule number two, is just a force that's due to the movement between particles. So it's similar to an electrical force where like like protons can cancel out with electrons, but the difference between magnetic and electrical is that uh, magnetic magnetic a magnetic force will there will always be some sort of effect, even at the atomic level, whereas in electrical charges they can cancel out. So it's in an electrical char in with an electrical with electrical charges the forces can cancel out, but in a um, magnetic force, it's like the positives and the negatives are two separate things from one another. So right hand rule number one, this is to determine the magnetic field. But what you're going to do is point your right hand thumb, in the direction of positive charge flow. It's also known as the current. And then you're going to let your fingers wrap around, and um, and the way that your fingers wrap around represents the magnetic field. So I just have a few examples of that one right here, and I'm going to do my best to show this with my camera set up the way it is, but I'll try my best. So in this first one, if you can recall, I stands for current, and then just a little tip. When you're dealing with magnetic fields and magnetic forces, if you've got a circle with an X in it, or even just an X by itself, then that corresponds to going, imagine going into the paper. And then when you've got one where it's a dot, think out of the paper. And so in this first example, we're going to have to determine what to put in these two circles. So we've got the current going to the right. Well, our first step is point thumb in the direction of the positive charge flow, so the current. So we're going to point our thumb to the right, and then it says let the fingers wrap around, and the fingers represent the magnetic field. So our thumb's pointing right, and then if we let our fingers wrap around, then imagine it as the this field that's going around is coming out from over here and then back into the paper underneath. So that means that this top one would be the circle, since it's coming out of the paper, and then this bottom circle would be an X, since it's like the field is going back into the paper. The second one, we've got electrons moving downwards and towards the bottom of the paper, and we've got to figure out what to put in these two circles. So, first step, point thumb in the direction of positive charge flow. Here we have the direction of negative charge flow, which means that to find out which way the positive charge is going, you just simply do the opposite of where the negative charge is going. So in this case, our thumb is going to be pointing up, and then let the fingers wrap around. So if I let my fingers wrap around like this, and then the fingers represent the magnetic field. So in this case, it seems like my fingers are coming out of the paper on the left side and then into the paper on the right side. So it would just be like that. For this third one, we've got protons coming out of the paper. So we've got positive charge coming straight out of the paper, which means that our thumb is going to be pointing up, and then we're going to let our fingers wrap around, and the fingers represent the magnetic field. So if our fingers wrap around, then it looks like this magnetic field is going counterclockwise. So instead of using dots and X's for this one, we're actually just going to use arrows to show which way the field is turning. So if we've got it like this, our fingers are pointing in a counterclockwise direction, so our arrows are going to travel in a counterclockwise direction. Okay, right hand rule number 2. It's similar steps, but it can be a little bit more confusing just because there's more involved. But you're going to point your thumb in the direction of positive charge flow, so same as the first step of right hand rule number 1. Point fingers straight in direction of external magnetic field, and then your palm will face the direction of magnetic force exerted on the moving charge. So whereas number 1 is used to find magnetic field, number 2 is used to find magnetic force. So this first one, we've got positive charge flow current moving to the right. In this instance, B represents the magnetic field, and then we've got to find out what the force is on the moving particles. So if we revert back to our steps, first thing we're going to do is point thumb in the direction of positive charge flow. So that's to the right. Our second step is point fingers straight in the direction of the magnetic field. So in this case, the magnetic field, it says it's going down. So we're going to open up our palm, and right now my fingers are pointing up. So it's actually, since we've got to keep the current going right, it's actually going to be like this. And then what we want to find out is what the force is for this exerted on the moving charge. And to do that, you just simply look at the way the palm is facing. In this instance, the palm is facing down. We know that to indicate that, we put an X. So for this second one, looks like we have the current and we have the magnetic field, and so we're going to determine what the force is. So our current is coming, just like in this example up here, our current is coming up from the paper. So thumb's going to be pointing up, and then our magnetic field is pointing right. So we're going to open up our hand and point our fingers right. And now we can determine which way the force is going, since whichever way the palm faces is the way that the force is going. So in this case, that the force is going up. And then in this final example, we've got electrons moving left, and then we have the magnetic field coming out of the paper towards up. So first thing we want to make sure is that we remember that we're going to point our thumb in the direction of positive charge flow. So that's to the right. We're going to open up our hand, and now we want to point the fingers in the direction of the external magnetic field. So that's symbolized by these two, which means that it's going to be coming straight at the camera, and it's kind of hard, but if you see this, then you can see that my palm is facing down, which means that the magnetic force is going to be going down. So there's the two right-hand rules for determining magnetic fields, magnetic force. Hopefully they made sense. The main difference is between the two rules is just this last step, to remember that magnetic force comes from the palm out. The way I kind of just think about it, if I ever, when I was first learning it, I just kind of thought of in Star Wars, when they use the force, their palm would be going out. Their palm would be facing whoever they're using it on. And I just kind of think of it like that. But feel free to just memorize this step if you want. You don't have to use that dorky method. If you have any questions, just comment. And yeah, thanks for watching.